So we're going to use this chart, and we need to get the VU divided by phi diagram up here. Let me try that again. So we need a VU over phi diagram. Oh, we need a VU over phi diagram. I'm just going to highlight it. We need a VU over phi diagram. We need to get a shear diagram. And here are the approximate shear values for ACI. Okay. You should know this, right? For a simply supported beam, W and L, the shear diagram for something like that is just WL over 2. And sure enough, the approximate shears are WL over 2, WL over 2, WL over 2. However, it says for the first interior face of the exterior span, that means this right here. You get WL over 2, but increased by 1.15. This is your shear diagram, except what I want you to do is make the shear in the middle of the beam, not 0, by doing this, okay? If you know the Muller-Breslau principle on how to load beams to get the greatest effect, you would know that to get the shear at the middle maximum, you would load over L over 2. Okay? And maybe in another lecture, I'll explain how I figured that out or how you can learn to do that. And what this shear diagram will look like is something like this. It'll be WL over 8 in the middle. It will not be 0. Okay, so the other shear diagrams that we've been drawing, they've been 0 at the middle. You can make the shear at the midspan not 0 by loading half of the beam. And if you have a feel for this stuff, you can understand that. If you get all the load on one half, you could shear it, okay? And so if you load different parts of the beams and you collect all the shear diagrams, it'll look like this, slightly curved. This is WL over 8, and this up here is WL over 2. And when we factor these, this will be WU, but this will be 1.6 W live, because only the live load can be put on half the beam, and the factor for the live load is 1.6. And what we're going to do, instead of trying to get that whole curve, we're just going to approximate it with a straight line like that, and that's going to be our shear diagram. And so the shear diagram that we're going to do will look something like this. WU L over 2, 1.6 W live L over 8. And on that one inside face, you can have the extra 15%. Okay, so these diagrams will look something like this. Where these midspan values are 1.6 W live L over 8. Okay, this is how you're going to get your shear envelopes or your shear diagrams, and then we'll use our table. But one last detail, the location of your maximum VU. Your beam is going to want to crack from the edge of the support up at 45 degrees. Can you see that all the red load is going to go straight into the column like this? okay? All the red load is going directly into the supports. Only the black load is causing the middle segments to want to shear down. It's like this load, and this load is not even there. It is not loading the beam in shear. It's as if it's zero, and when the load is zero, the shear diagram's constant. And what that means is, it's like there's no load there, so that would be flat, constant. Like that. Like that. There. And so this would be your maximum shears right there. It's a significant difference, okay? And what this is supposed to say, well, here, let me show you this. What this is supposed to say, it's worded weird. It's VU at D from face of the support. That's what that sentence is supposed to say. Sorry. Okay. Last thing I want to do is just touch upon, we won't go into any detail, and it's not part of this course, but I do want you to be aware of shear design for seismic regions. There are different requirements. First of all, you are not allowed to use stirrups. So here's a stirrup. Okay. No. You have to use closed hoops like this. And you have to use these hoops for a distance of 2D from the face of the support. Okay. And they are very closely spaced. Here are the rules. The first one is at 2 inches from the face of the support. That's my dog Bentley, sorry about that. And they're spaced the minimum of these 4 things. D over 4, 8 times the diameter of the smallest long bar, okay. 24 times the diameter of the hoop bar, which is probably a number 3 or a number 4, or 12 inches, whatever's the least of these 4. And this is wrong. That's the 2019 code has a different number. I'll just say by ACI code. And when you no longer need the hoops, when you're past that 2D from the face of the support, you can go back to regular stirrups with a max S of D over 2. That concludes our lectures on shear concepts and basics. The next 2 lectures will be examples.